Hi, testing 1, 2, 3, testing 1, 2, 3. Hopefully this works. Good morning, Dr. Larson. Is Isaiah here? I might as well just go ahead and get started with getting this thing. So let me go and go here, and let me try to get the screen going. All right, share screen. Here we go. All right. I'm assuming this is screen as I can see. Um, Again, good morning, Dr. Larson. It's Isaiah. My project is on GPS technology and exercise and sport, but they're also called wearables, but we will discuss this later throughout the project. So let's go ahead and get into it. All right, so first I just wanted to introduce my thesis statement, which was at the end of my introduction. And all it is wearable technology or a GPS unit in this case, because I'll be focused on sports GPS unit. For exercise provides valid and reliable metrics for increasing your fitness and performance. And sorry if I can't look directly at you because the way that my friend's camera setup is, he has something over here, so I can't look directly at the camera. But I can only see it here. So yeah, so GPS units will help increase of human fitness and performance. And how does this happen? We'll explain a little bit later throughout the presentation. The main thing is allows for again us to use metrics to scientifically and mathematically analyze what's going on with the body when it comes to movement or locomotion. So a GPS unit is this type of wearable technology again, and it tracks quantifiable metrics. So again, statistical things, numerical things, numbers, right? We're tracking force, we're tracking acceleration, we're tracking velocity. All these things are dealing with numbers, right? So we're using these numbers or these metrics, and we're applying it into our training program. Trainers can use these, coaches can use these, scientists can use these, sports scientists, exercise scientists, whatever the case may be. But the purpose of using them is again to improve human fitness and performance. So again, like I said, we can track and monitor metrics. Um, Products that are, what you call it, with wearables. Could be GPS or Apple Watches. Because I'm talking about sports, we're gonna be talking about GPS, which is a global positioning system. But Apple Watches can be used by athletes to help monitor heart rate or what things like that or whatnot. But the main two things that you'll see is GPS and Apple Watch. You won't really see a Fitbit or smart glasses or something like that. We also want to look at the validity and the reliability. There's not a specific slide for this, but we'll see it throughout the whatchamacallit presentation. And then again, used mainly in exercise and sport. You don't really see GPS used in non-competitive sport. You see it used in competitive sports, basketball, football, baseball, track, right? Things where you don't need these analytics, but it'd be very good to use these analytics to get the edge on your opponent. And then finally, again, like I said, we're gonna keep on and hammering down that it helps to enhance human performance. All right, so now let's go to our background. Well, the background, okay, well, a GPS tracker dates back from the pedometer and is in a modern version of it. On the right, we have what the GPS tracker looks like from the company called Catapult. So what's the origin of wearables? Well, again, like I said, the successor of the pedometer, which is from the 1700s, all right? Um, first modern thing came from Japan, with Dr. Yoshiro Hatano, which was actually from, I believe, Kyushu University. I don't think I'm pronouncing that right, but he essentially came up with this model version of the pedometer. This was around the time where they were talking about 10,000 steps a day. So we even had an early basis of metrics that would influence us in the future, right? And again, this influencing by other people allow for us by earlier technology to be able to progress as time went forward. So what the engineers did back then helps us now. What is a wearable? It's any electronic device that attaches on the user's body. So on my clip, what's on my waist, on my neck. I know with GPS units, they have something that we call those sports bras because that's what they look like. You put it in the back, but sometimes you could clip it on your shorts, whatever. Again, these are GPS more used in sports, smartwatches more used in non-competitive exercise. And the important thing, it collects real-time data, collects real-time data. What does a wearable accomplish? Again, monitors locomotive metrics like relative distance, acceleration, velocity, player load, right? And it's actually more compatible with slow speeds. So like longer distance athletes, right? Say if I was doing a distance run versus a sprint, the wearable will be able to it'd be better, it's more compatible for that longer distance person as opposed to fast speeds. And the reason why is because longer distance, it's less spontaneous, right? So it's more, the environment is more controlled. With a fast sport, football, basketball, you have quick cuts, all these different things. It's so spontaneous and random that sometimes the thing doesn't pick it up. Like if you ever had a pedometer or Apple Watch, you took a bunch of mini steps, right? It might not count all those steps. And part of the reason why is because it's so fast, it's so spontaneous. But if I take a long step and I put the force in the ground, the Apple Watch is probably gonna count it. All right. So let's get into inside metric trackers. Well, the interior of a GPS unit contains instruments such as gyroscopes, triaxial accelerometers, and magnetometers. Some of them also have heart rate monitors, but for the sake of now, I didn't put it there. This is what the inside of a GPS looks like. Again, they have smaller components. So a triaxial accelerometer is a three-dimensional tracker. It tracks on all planes. So on the X plane, on the X coordinate, on the Y coordinate, so on the vertical, on the horizontal, and on the diagonal, which is the Z coordinate. Right. So it's three-dimensional, perfect for us because we're three-dimensional. It records players' impacts, collisions, acceleration, all these other different things. It's linear base, right? Even though it's in multiple directions, all of this is linear, right? It's not happening in a rotational thing, right? So that's where we have gyroscopes for. Gyroscopes, unlike triaxial accelerometers, help monitor rotational kinematics, rotational dynamics, right? So we talk about force being produced in a rotational way. We're talking about motion being produced in a rotational way. So if I talk about my torque, right, the torque that I'm able to produce as a baseball player, I'm not a football player, well, actually a football quarterback, right, or as a golf player, as a tennis player, all that torque that I get from rotating my body, right, that can be it can be tracked by a gyroscope. The only problem with the gyroscope is that it's uncertain. We're uncertain about its validity and reliability. Then a magnetometer, it detects the position using microsensors. It's kind of like, a satellite. That's what it's kind of like. It helps what you call detect the position of the player, where he's at on the field, where he's at on the court, where she's at, just the locomotion, the orientation of the body. So how to effectively use a GPS, because this is what we're trying to get. We're trying to prove that GPS helps help human performance, movement. All right, so let's first look at sampling frequency. I said we were talking about validity and reliability, and here we go. So sampling frequency is the amount of pings that are tracked per second. So say if I have 1 hertz and it's measured in hertz, so if I have 1 hertz, that means I'm getting 1 ping per second, which means I'm getting 1 point of data per second, right? That's not really that good when we start talking about high speeds. We want to get really into the analytical and statistical portions of the tracking so that we can be able to enhance our training programs, right? So the higher the hertz, typically the more accurate it is, the more which more valid and reliable it is. Because in any scientific what you call research or whatnot, we want to have an adequate amount of samples or data points, right? 1 is not enough. So when we have 5 hertz, we have 10 hertz, right? Those are more accurate. It goes up to a 15 hertz, but sometimes too much data can mess you up as well, right? So again, measured in hertz, 10 hertz is 10 points of data per second, right? 5 is 5. And yeah, so this is what helps the validity and the reliability of the GPS tracker that you're using. So how does training programs, how does this affect training programs? Well, if we can actually get quantifiable metrics, then we can potentially create a better program. How so? Because we can administer to the amount of induced stress that is being exerted on the body. Say, for instance, if I want to make a controlled environment for my football player, right? If I was able to physically see versus looking at the data points, right? The difference between the human eye and then statistical data, right? On how much times he's cutting, how hard he's cutting. Like it's hard for the human eye to even, oh, I see how hard he's cut. He's putting X amount of newtons into the ground, right? He has X amount of force in newtons in the ground, right? Or he's going at this amount of acceleration or this amount of velocity. No, the human eye can't really track that, right? Not as accurate as data can, right? So we can take those numerical values, right? And we can, use equations, you can use science, you can use math to help make a better training program so that the athlete doesn't overtrain, right? Because that's what happens. Oftentimes we overtrain the athlete and the athlete doesn't increase in human performance, nor does he get better at movement. He actually gets worse at sport, he or she, right? But then on the flip side, you don't want to overtrain, so sometimes you end up undertraining and now you're not getting enough what's stimulus to elicit an adaptation, right? So these metrics can allow for us to find that sweet spot in the middle, which can help increase physiological adaptations, which means reduce the risk of injury and increase athletic performance. And let's just get some final thoughts up. GPS units provide great potential to enhance training programs. Therefore, they can lead to evolution in human performance. I didn't mention this in the video. However, they're not needed. GPS units are not needed. They're more popular nowadays. And they have great instruments to aid in training efficiency, right? So they're not something that is needed. You can actually get the same results, maybe even better without it, right? But the way that the industry is gone right now, the way that the industry is moving, the way how the fitness industry is, promoting Apple Watches or GPSs, right? They're helpful instruments that can be beneficial to your coach, to your athletes, to your scientists, to your training, to your trainers, to your athletic trainers, whatever, right? So that you could all be on the same page when it comes to data wise, as opposed to, what I've seen with my eye. What the athletic trainer sees with their eyes, not what the coach sees with his eye, which is not what the scientist sees with his eye, right? So this data points could help with that. So yeah, again, GPS is not needed. It's a very good instrument. I would highly recommend it. Only reason is because I see my coach that I work with, my internship, and we use it. And it's beneficial, but you don't need it. Thank you so much. I know I kind of went on a little tangent, a little rambit. I had to for Dr. Larson, I had to blow up my whole 4 main points thing because I just realized that what I was trying to get at in my thesis statement, the other ones really wasn't gonna help. So I continue with this. Hopefully it was good enough. But thanks for listening to my rambling for a couple of times. I hope it's recorded. And I'll catch you all later.